Hello students, welcome to Shore of Sir's classes. You can reach us at www.shoreofsirclasses.com or call us or WhatsApp us in case of any queries or clarifications at 9836793076. You can also email us at shoreofsirclasses@gmail.com. So today we will be solving some IIT JAM Chemistry questions from this year, that is 2018. Let's move on. We have question number 49 in hand. The value of Cv for 1 mole of N2 gas predicted from the principle of equipartition of energy, ignoring the vibrational contribution is. So we have to find the value of Cv for 1 mole of N2 gas predicted from the principle of equipartition of energy, ignoring the vibrational contribution. So we will basically ignore the vibrational contribution and never consider it now. So we will have to round up the answer to 2 decimal places. So starting, we know that N2 is a linear diatomic molecule. So the number of atoms in N2 will be equals to 2. So the number of translation degree of freedom will be equals to 3, and the number of rotational degrees of freedom will be equals to 2. And since we have to ignore the vibrational contribution, so we will not consider it at all. So Cv equals to 3 into R by 2 plus 2 into R by 2, and R is given as 8.3 joule per Kelvin per mole. So this is equals to 3 into 8.3 by 2 plus 2 into 8.3 by 2. So effectively this will be equals to 12.45 plus 8.3 joule per Kelvin per mole. So this value will be equals to 20.75 joule per Kelvin per mole. The next question is question number 50. Assuming ideal gas behavior, the density of O2 gas at 300 Kelvin and 1.0 atmosphere pressure is, and we have to find the value of the density of O2 gas at this temperature, that is to a 300 Kelvin temperature and 1.0 atmospheric pressure, and round it up to 2 decimal places, and the value of R is given, and the molar mass of O2 is, we all know, is 32. So we know that PV equals to nRT, and N is the number of moles, P is the pressure, T is the temperature, and R we know is the universal gas constant, V is the volume. So now the number of moles equals to the mass given by the molar mass. So we'll call this capital M and this one as small m. So replacing N here by small m by capital M, we have PV equals to M by capital M into RT. So capital M by RT into P is equals to M by V, and this is the mass given and this is the volume given. So this will effectively be density, because density or D, density equals to mass by volume. So this is D, this is small m, and this is V. So D equals to Pm capital M by RT. So D equals to P capital M by RT. Now we have been given that T equals to 300 kelvins, pressure equals to 0.1 atmospheric pressure R has been given as 0.082 liter atmosphere per mole per Kelvin, and the molar mass of O2, that is the capital M, is equals to 32. So putting these values in this equation, D equals to P capital M by RT, we will put P equals to 0.1 atmosphere, molar mass of oxygen will be 32, R is given as 0.082, and temperature is 300. So density will be in gram per liters. So this is equals to 1.30. So density is equals to, density of O2 will be equals to 1.30 gram per liter. So the answer is 1.30 gram per liter. Thank you.